Hey everybody, this is Christian, and today we are diving into the world of Git, which is undoubtedly one of the most crucial tools we have in the professional IT landscape, not only for software development, but also for sysadmins, network admins, yeah, even IT support people should learn Git. Because let's face it, yeah, everything nowadays becomes IT as code, so understanding Git and source control is more important than ever. In this video, I'll explain what Git is and what it makes so special, and of course we'll also have a look at some basic commands so you can directly start using it for your personal projects to track file changes, organize your coding journey, or also manage dot files. Yeah, there are a million ways of how to use Git, and of course this is only the first episode of a brand new tutorial series, so there's a lot more to come in the future. I hope you're ready for it. Let's get started. But before we start, I quickly want to show you NetBird, a zero configuration VPN that helps you securely access your IT infrastructure from remote. I know we've talked a lot about other VPN solutions before on this channel here, but NetBird has some very interesting features for home lab people that make it kind of special. So first, it's free and open source, which is always a good thing. And even though it has a cloud-hosted version, which you can, by the way, use for free to get started instantly, unlike many other solutions, you can also set up this entire thing on your own and completely self-host it. It's based on WireGuard, which creates high-performance peer-to-peer tunnels between all your devices, and you can create access control rules where you can decide which groups can access which protocols and ports. That is really amazing, and the best, you don't need to open any ports on your firewall, it just magically works. This quick start self-hosting guide here gets you a full setup with single sign-on and multi-factor authentication up and running with just one single script, and then you can just deploy the software on your servers, install it on your clients, connect, and get access to any local resources you need. NetBird has a great documentation about all of those things, so just try it out yourself. Of course, I will leave you a link in the description down below. Okay, so first of all, I want to quickly explain what Git is and how does it actually work. Git is what we call a free and open source distributed version control system, or also shortly called a VCS. A VCS is often used in software development for managing projects and managing source code. It's a very important part of the progress because at its core, a VCS is responsible for looking at the files of a project, and it can track when someone has made a change, for example, when a line was changed, deleted, or added in a file. A VCS will store all those changes in a history, and you are able to compare those changes with previous versions or understand who has made those changes in your project. And of course, you can also go back in time to a previous revision of that file. So you can imagine this is very crucial in software development, especially in complex projects where multiple people are working together and there are many people changing the source code. But it is also very useful for any other purpose if you want to manage a project with multiple files that you often change. For example, in tech documentation, dot files, and you want to have some kind of logging and updating progress. It's very important to understand what makes Git special from other traditional VCS systems that are more centralized, because Git is a distributed VCS. So some of you might remember older systems like Subversion, CVS, or Perforce. So these centralized version control systems rely on a central server where they store a single truth of all these file versions. And when a client wants to work on the project, it usually requests just the latest version of these files before they commit any changes. And this introduced some significant problems, mostly because it has one single point of failure. So when the central VCS server dies, the whole project history or the project repository is lost. But there are also many other problems like limited access and speed scaling issues because of this centralized architecture. And that makes this system kind of old school, yeah? And that's why Git follows a different approach where there's not just a single source of truth for all of the files. Instead, each computer in the Git managed project holds the entire chain of the file versions, including all the revisions, all the changes, all the logs and histories that has been made. Everything is locally available to these computers, and that makes it much faster, and it also ensures redundancy in data integrity. It also empowers each contributor to independently work on these projects. And of course, if the server computer dies, which hosts the repository, well, that's not a big problem in Git because you can restore the entire repository with everything from each of those computers that has this repository. That is why Git is so widely adopted in the tech space by professional and big tech companies, service providers, free and open source organizations, and also individual people who just want to manage their own personal projects. Git is just everywhere in IT. If you want to get started with Git, you can just go to the official homepage git-scm.com, and there you can easily download the client to your local workstation. Just navigate to downloads and you will find some installation guides and procedures for macOS, Windows, and also Linux. On Windows, you simply just download the executable installer, just go through that, or use a terminal command like winget install. On macOS, it's really the easiest way to just use brew install git, or you can also just install the Xcode command line tools that will also ship with Git. And on Linux, of course, you can use all the different package managers depending on what type of distribution you're using. That's how it works on Linux. And once you've installed that, you can just open a terminal and then type in the command git. So that should get you an output, and that indicates, okay, Git is successfully installed. You also get a list of all the common Git commands, but don't worry, we will go through some of this stuff here in this video tutorial series, because one thing that you need to understand is Git can be quite complex because it uses a lot of specific terminologies, workflows, and progresses that you first need to get in your head to actually make use of it. So that's why I thought let's start with a very simple project and let's create a local Git project. Before we do that, however, you first of all should configure Git. So this is really useful because it makes the collaboration easier later. And if you make any changes to a Git repository, all those changes are associated with your user and email address. And if you configure that first, it's going to be easier for you later to identify what you have changed and so on. So first of all, type in the command git config --global, and then you need to configure two attributes here. So the first one is the user.email address. So you can just set this to your personal or business email address. And the second is the user.name. So I will just set this to my real name, but feel free to use anything that you like. You can also get a list of all those different attributes and configuration settings that you have configured on your Git client with a git config --list. So this currently prints all of the stuff that I've configured as my username and email address, but also other things like my code editor, the credential helpers, and so on. If you want to get a list of all those different configuration settings, you should refer to the official documentation. But those two things are the only thing that you really need to get started. So now we can start creating our first project. And one thing that I probably should mention at this point, because a lot of people refer to Git as GitHub or GitLab to manage remote repositories, but it's actually not true. Git is not the same as GitHub or GitLab. So Git is really the foundational free and open source VCS system, and GitHub or GitLab are service websites or service providers that use Git as a software, but on top they provide a lot of other very useful services. We, by the way, will also take a look at GitHub and GitLab in future episodes of this series, by the way. But first of all, to understand how you actually work with Git, you should always start with a local project and not use a remote project. That's going to be a lot easier in the first place. So to initialize a new local project in Git, we will use the command git init. So this will initialize an empty repository somewhere on your local file system of your workstation, and we will name this git repository test-1. If we hit enter, you can see Git initialized a new empty repository in that current path, so where I've executed this command, and it also created a new directory. So let's go in this directory. And as you can see, this is empty, but if you execute an ls-a command, you can see there is a hidden folder that is called .git. And in this folder, Git stores all the configuration, the history, the file tracking changes, everything that it needs for this repository. And you can also see, once I entered this Git repository folder, that my terminal prompt changed a bit because I've installed an extension to my terminal that looks for if there is a .git folder somewhere inside. And if it is, it prompts some information about this Git repository here in my prompt. So as you can see, this now indicates with the Git logo, I'm currently in the main branch. And what you can always do is, if you're inside a Git repository folder, you can execute a Git status to see what is the current status of your repo. I've not committed anything yet, and there is nothing that has been changed because it is a completely empty folder for Git. Now let me demonstrate some basic workflows how to use Git to track version changes in files. For example, so this is our project folder where we want to upload some source code or we want to track changes in specific text files. If we add a file to this folder, for example, I will just add an empty test file here, and we execute the git status command. Again, you can see that Git now recognized something has changed in this folder. This file is currently not tracked, so Git is not monitoring this file yet for any changes. You need to add it first to this Git repository. So let's execute the git add command, and then you can simply just type in the files that you want to add to the tracking. And as you can see, the prompt also changed a bit now. Let's execute a git status again. As you can see, there are a few changes that we want to commit. Let's hold on for a second. What the hell does it mean to commit a change? What actually happens when you add a file to Git? Those kind of terms and progresses were always a bit confusing and weird to me, especially if you have no software development background. So that's why it's really important to familiarize yourself with the way how Git stores data, how Git processes data before you start using it. Otherwise, you end up being completely confused and making a lot of mistakes. Files in a Git repository can be located in one of three main stages, and it's very important to understand the difference of those. So first of all, let's start with the working directory. So this is the current directory where you are working with your files. You can see and modify them freely. And now let's say you made some changes or fixes to one or more files in the working directory. These changes are just in your local environment at this point. And to prepare them for a commit, you need to first of all move them into the staging area. So this is done by executing the git add command. That is what we've just executed on our test file. And you can continue working on those files and add more files to this staging area. And finally, when you're satisfied with all the changes you have done, you commit them. And this is done by executing a git commit command. So this takes everything you have staged into the repository. From then, the commit is then part of your project's history as a new snapshot at that moment in time. So in an organized development, you can work on features while you only commit those that you have completed. And other developers can, continue working in their own working directory or staging area. That is really great for parallel development. So what we've basically done is we moved the test file from our working directory into the staging area, and we are now ready to commit this change to the repository. So how to do that? You simply type in the command git commit, and then you also should always add a note or a test, so to refer to this commit later in the history, and you can easily identify what you have done in these changes. For example, let's just add the text created test file. So now you can see I've made a new commit to this repository and it's now part of the history. If we now execute a git status, you can see that there is nothing to commit yet. So that means that the current working directory is in line with the latest commit that has been made to the repository. Let's also take a look at how Git actually stores those commits. For example, imagine you have a project tracked by Git with 3 files. Let's call this initial setup version 1. And now you decide to make changes to one of these files. Let's say file 2. You first of all move them to the staging area and then you commit them to the project. So once you've done that, Git takes a fresh snapshot of the file 2. We simply call file 2_1 since you have changed it. But for file 1 and 3, which you didn't touch, Git doesn't bother to store them all over again. It just keeps a reference to those files as they were in version 1. So in version 2, you've got a completely updated file 2, but file 1 and 3 are just carried over from the last version. And this approach is super efficient. It's not just saving space, but also making your commits and accessing past versions really fast. And from there, it just goes on like this. Let's say in version 3, you just change file 1 and 3. In version 4, maybe it's file 1 and 2 that gets updated. Each time you commit changes to a repository, Git only stores a new snapshot of the files that actually changed, keeping everything else just as a reference into the previous version. Now let's, for example, make some other changes. For example, I want to add a line in this test file because it's currently empty. And I'm just telling, hey, this is my first Git repository, and pipe this into the test file. So now you can see the lines in this file have been changed, and if I execute a git status, you should see that Git recognizes, okay, so there is a test file existing that I'm tracking, but this file has been modified. And if you want to see what actually has been changed in that file, you can execute a git diff command. So this will show you if any lines have been added, altered, or deleted. And as you can see, this plus indicates I've added one line to this test file. And now if I want to move this change from the working directory into the staging area, again, I will use the same command, git add, and then the file that I want to add to the staging area. You can see this file has been modified and the changes are ready to be committed. I can now commit it to the repo. But if for whatever reason I'm not done with the changes, or I recognize, oh, there's some mistake I've done, I want to move it back from the staging area to my working directory, you can use the git restore command --staged and move the test file from the staging area back into the working directory. And you can also skip the staging area, which is something I probably would not do on a production environment, but you can do it if you want. So you're 100% sure what you have made and you want to directly commit it. You can also type in git commit and then add the -a flag, add a text, changed text, for example. Let's hit enter. And as you can see, that now has been committed. If we execute a git status, we have no pending changes. Now you can also do some other cool things with Git. For example, if we accidentally delete this file, for example, let's remove this test file here, and yeah, I've accidentally deleted it, I want to restore it. I could now move this change into the Git repository, but if I've done this accidentally and I want to restore it, I just type in git restore and then the test file, and you can see now the file is back in my working directory again. You can also use Git to rename files. One thing that is important to understand, I quickly want to show you, if you move this file, but you're not working with a Git command, you're working with a Linux command in your current file system, and you move this to test2, for example, and you execute a git status, guess what will happen? Git will recognize, oh, there has been a change. I deleted the test file, and I created a new untracked file. So if I would stage and commit this, the repository would be empty because the test file was deleted, but the new test2 file wasn't added as a tracked file to the Git repo yet. So let's undo this for a second. And the way you can easily do this in Git is you just type in git move and then test to test2. So now if we execute a git status, you have not executed this in a file system command, but with a git command, Git will recognize, okay, you want to rename this file, and now you can easily just add this change as a new commit. Or you can also do the same if you want to remove this file, git rm test2. You can see, because I've already made changes to this file that haven't been committed, I need to force this. But let's not do it. Let's first commit our changes so we are following a correct workflow. Now that I have committed the renaming of the file, I can remove it. And if I really want to delete this, I need to commit this again. Now this is how you do basic file operations in Git, how you rename, remove, and add files to the staging area, and how you commit those changes. As I said, everything that has been added as a file to the Git repository is being tracked, so every commit that we've just done is in the history of this repository, and because we've just deleted that file, maybe we want to get it back. So let's also take a look at how do you undo changes in a Git repo. So first of all, we should get a list of all the commits that we have done to this repository. And this is what you can easily do by executing a git log command. So this will show all the commits that we have done in this repository. So this is where we created the test file. This is where we changed the text to the file. This is the name that we've changed from test to test2. And this is where we deleted that file. You can see the latest commit also has a head that points to main. And I'm not going into details of branches here in this tutorial, but the head indicates the current position of the pointer in Git. So that means we are currently working on this branch here. You can also format this history log in different ways. So for example, if you execute git log and add the flag pretty, format this to one line, for example. So this is a shorter, compressed version of that list. It just gets you the commit ID, the head, and the comment that you've added to this commit. You can also use an extended version of that with a git log and use the patch flag. So this will get you a longer list with not just the commit IDs and the details when you have made this change, who has made this change, but also the specific changes in those files. So for example, here we have added this line here to the text. You can also show all the changes in one specific commit with a git show, and then you just need to use the ID of the commit. For example, if you want to see those changes in that commit here, we just copy this ID and paste it here. Now we get an output of when we've made this commit, who has made it, and what has been changed. Now let's assume I want to undo those changes. For example, I have deleted this test file and I want to restore it. How do I do it? So first of all, I need to find that specific commit when this file was still in the repository. So I need to find that timestamp where everything was still okay. And let's scroll down through that list. We can use the git log command to identify that. And this is why I told you before it's so important to add a comment to those commits, because otherwise you never really know. So what was the commit where I had this test file? So that's why I want to go back to this commit here where I changed the text. So this is where I've added this to the test file. Let's pick this commit ID here. And then we can use the command git reset. So this resets the pointer to this specific commit ID. And I know there are different possibilities on how to restore file. I just want to show you this way in this tutorial. In a future episode, I will also show you a second way how to restore files, which is a bit safer. So this is a more drastic way to restore files because it's currently resetting the whole pointer to a different commit. And as you can see, we have unstaged changes after reset, so we deleted tests. So what the hell is going on? As you can see, it didn't do anything on our working directory, and that is because the reset command by default will not make changes in the current working directory. Remember, we have those three stages: working, staging, and the repository. And our current working directory hasn't been changed by this command. What has been changed is when we execute git log command, you can see that the head pointer now is back in time to this older commit. I don't really see those commits I've made after this time anymore. You can still get them by using the git log --ref log. So this will show you all these commits, but you can see as the head is now here at this commit, this is where the pointer currently is. But you can also reset your current working directory back in time to this commit to continue working on this. However, you need to be very careful doing this because this overrides your current working directory. So if you have made any changes that you haven't committed to the repository yet, what I will show you now will override them, and this is where you actually can lose some data, so be careful doing this. However, we are 100% sure that we want to go back in time to that specific commit because this is where the file was still existing. I can do a reset to that commit, but now I'm adding the parameter hard. So this is also called a hard reset. And when I execute an ls command, you can see our test file is still there, and it also still has the text that I've added to that file. So when I now want to make changes, for example, we are back in time, we have our test file, I want to create a second file. For example, let's create test2, and let's also echo some test in this file. And I also want to add one more line appending this to the file. So if you want to now move those two files into the staging area, you can use a git add dot. So this will move the entire directory, so all the files in this current directory, into the staging area. Now those two changes are in the staging area. They are now ready to be committed, so let's commit them. Two files have been changed. And as you can see, I now have added a new commit in this chain. Okay, so that was the first episode of my new Git tutorial. I hope you now get a bit more clarity about what Git is and how does it actually work, how to use some basic commands to track file changes and do commits. In the next episode, we will talk about branches and get in a bit more specifics. I hope you're ready for it. Don't forget to hit the like button and subscribe if you want to watch more tutorials. And if you want to support my mission to create all these tutorials entirely for free, why not join our Patreon program that always helps me to create all these resources. Thanks to all the people on my Patreon program for your support. You guys are just incredible. Thanks for watching. Enjoy the rest of your day, and I will catch you in the next episode. Take care. Bye bye.